Good afternoon, everyone. Welcome to the contributory paper session 7. The first presentation is number CP39, Rhea Kuruvilla. Rhea Kuruvilla.
Yes, ma'am.
Check your audio and video. And please share your presentation.
Yes, I will share the presentation. Is it visible now?
Yes. Presentation is visible. You can start your presentation now.
Okay. So good afternoon, everyone. My name is Rhea Kuruvilla, and I am doing research under the guidance of Dr. Vishwanath C. Narayan and Government Engineering College, Thrissur. The topic of my paper is comparison of vacation and MT-MT1 queuing models for traffic flow at signalized intersection. In this paper, we studied a traffic model as an MM1 queue with server vacations to analyze congestion at traffic signals. Customers, which are vehicles here, arrive at a server, which is a traffic signal, according to a Poisson process with parameter lambda. The customers receive service only if the server is not on vacation. That means when the signal is green. Service time is exponentially distributed with parameter intersection represented as a queuing model. The server goes on vacation. That means the signal will turn red after a random duration, which is exponentially distributed with parameter nu1. Vacation duration is exponentially distributed with parameter nu2. The server adopts a single vacation policy. We model the above problem as a continuous time Markov chain. For this, we define N of t equal to the number of customers in the system, including the one getting service, if any. S of t equal to 0 if the server is on vacation or red signal. 1 if the server is busy or ready for service. Let x of t equal to set of all n of t. S of t says that t greater than or equal to 0 is a continuous time Markov chain with a state space E equal to set of all ij, I greater than or equal to 0, j equal to 0, 1, and infinitesimal generator Q, which is given over here with A10, A0, A2, as well as A1 are the square matrices given accordingly. Stability of the Markov chain, which is given as a theorem. X of t is stable if and only if lambda less than mu nu2 by nu1 plus nu2, and its proof is given here accordingly. Transient probability vector. Let the transient probability vector of x of t be x of t equal to x naught of t, x1 of t, x2 of t, etc., where xi of t equal to xi 0t, xi 1t for I equal to 0, 1, 2, etc. The probabilities xijt satisfying the following system of equations. The above system can be solved using Laplace transform techniques. For our computational purposes, we applied the external uniformization technique, since the analytic method mentioned above required inverting Laplace transforms. Steady state probability vector. Let the steady state vector of x of t be x equal to x0, x1, x2, etc., where xi equal to xi0, xi1 for I equal to 0, 1, 2, etc. Xij is the probability of finding the system in state ij in the steady state. It follows from Newt that xi equal to x0 r raised to I greater than or equal to 0, where r is given with which is a solution of the matrix quadratic equation r square a2 plus ra1 plus a0 equal to 0, where h as well as x0 is given nu2 by nu1 plus nu2 1 minus rho matrix nu2 by lambda plus nu2 1. System performance measures are average number of vehicles in the system is mu EC of t equal to sigma equal to 1 to infinity I xi of t e. Average number of vehicles in the steady state is mu EC equal to rho by 1 minus rho plus lambda nu1 by nu2 into nu1 plus nu2 by 1 minus rho. Probability that the signal is green at time t is Pg of t, which is given as a sigma expression. The steady state probability of finding green signal is Pg equal to nu2 by nu1 plus nu2. Now waiting time in the system. Consider a Markov chain y of t equal to set of all np of t, s of t says that t greater than or equal to 0, where np of t denote the position of the tagged vehicle in the queue and s of t is the signal status. NPFT is equal to N if there are N-1 vehicles ahead of the tagged vehicle. The possible values for NPFT are this 1, 2, 3, etc. up to N. Assume that Y of t enters a state star and absorbing state when the tagged vehicle crosses the signal. The state space of Y of t is star union set of all I tilde such that 1 less than or equal to I less than or equal to N, where I tilde is equal to set of all ij, j equal to 0, 1. The infinitesimal generator of Y of t has a block structure given by Q bar, which is given as a matrix 0, 0, T naught T, where T is the matrix given, where A1 tilde and A2 as defined accordingly, and T naught equal to minus TE. Let WT be the column vector given by WT equal to minus T inverse E. Partitioning WT as WT equal to WT1, etc. T, and it follows that WTN is equal to I plus N minus 1 into G minus A1 tilde inverse E, where G is matrix 0, 1, 0, 1. WTN is a two-dimensional column vector whose first and second entry denote the average waiting time of a tagged customer who finds N-1 vehicles ahead of it and the signal as red and green respectively. WTN can be obtained explicitly as the expression given over here. Taking the probability that the tagged vehicle arriving at time t finds N-1 vehicles ahead of it as xn-1 of t, the average transient waiting time of an arbitrary customer is given by ds of t, which is expressed here as equation 1. Considering the steady state probability vector xn-1 in place of the transient probability xn-1 of t, the average waiting time of an average customer in the steady state is given by ds with the sigma expression, and it is simplified, and accordingly we are getting an equation which is expressed here as equation number 2. Notice that though the waiting time may be derived, opting for matrix analytic methods, the recursive renewal reward technique is better since it doesn't require the steady state distribution. The method presented here has the advantage that it can be used to find the transient time delay as given by equation 1 in the previous slide. The MT-MT1 queuing model, consider an MM1 queue with time-dependent arrival rate lambda t and service rate mu of t. We assume that mu of t is equal to 0 during the red periods and remains constant during the green periods. Transient solution of the above system can be found in Zhang and Coyle, which involves computation of a Volterra integral equation. Here also we applied the external uniformization method. Now this is the graphical representation of a transient behavior of mu ECT in a vacation queuing model. And this graph is actually a graph representing the actual vehicle flow pattern at a four-legged signalized intersection at Idambaram Junction, Ernakulam, Kerala. Video recordings done on this place to compare different models revealed that the duration of green and red periods were 30 and 75 seconds respectively. Now, this graph representing the real world scenario is entirely different from the transient behavior of the vacation queuing model that is shown over here. And now, this figure 3, suggests that in this figure you can see blue lines, which is actually the lines representing the MT-MT1 queuing model, and the red dotted lines represents the Moody and Savla 2017 model, and the thick brown line represents the transient behavior of the vacation model with respect to a particular lambda 8.6 per minute. And as you can see, the Moti and Savla and the MT1 queuing model imitates the same behavior that we have seen in the previous graph. But the transient behavior, now this graph representing the real world scenario is entirely different from the transient behavior of the vacation queuing model that we have seen here. So this figure 3 suggests that there is not much difference between the Moti and Savla 2017 and the MT-MT1 queuing model, whose behavior imitates the real world picture. The brown thick line in the graph representing the transient measure from the vacation model gives over prediction and deviates from the reality. So the conclusions are, our numerical study shows that there is not much difference between the pure birth and MD1N combined model and the MT-MT1 queuing models, and that their performance imitates the real world situation better than the vacation queuing model. Since the pure birth and MD1N combined model has the disadvantage of being a combination of two models whose transient distribution lacks analytic expression when started anew with a general distribution, the MT-MT1 queuing model could be thought of as its replacement. The MT-MT1 queuing model opens up several options for future research, since arrival and the service rates in the model can take general time-dependent forms. These are my references. Thank you.
Thank you, ma'am. Any queries? Okay, thank you, ma'am.
Okay.
Next, we
Thank
have
you.
presentation CP40, Pranati Jalapalli.
Yes, ma'am.
Okay, ma'am, you are audible. Please share your presentation.
Yes. Okay. Okay. Good afternoon, everyone. My name is Prati. I'm a research scholar from CSIS department. My topic is about fuzzy fractal dimension of COVID-19 variant proteins. Now, as we know that COVID-19 is called the severe acute respiratory syndrome coronavirus 2, which emerged from China December 2019, which has created substantial and serious threat to global health. All the virus, including the COVID-19 SARS coronavirus, evolved over time, and these modifications have minimal to no effect on the viral characteristics. In virus, during every mutation, the virus replicates. There is a chance that the genetic code won't be copied accurately, as the mutation is nothing but it is the addition, deletion, or substitution of amino acid that takes place in the virus. Viral protein. The SARS coronavirus variants are emerging and gaining traction around the world due to the mutations that are taking place in the viral protein. And some of these mutations are harmless and some are increasing infectivity. And they are escaping the immune system of humans. And these variants are being classified into two types, variant of concerns and variant of interest. Variant of concern, here we will get alpha, beta, gamma, delta, and Omicron variants. Whereas in variant of interest, we have kappa variant, Iota variant, Iota variant, and all these comes under variant of interest. Here comes the problem description, where in our research, we analyze the protein structure of COVID-19 variants to fuzzy fractal dimension of protein structure network. As we know that the fractal dimension, fractal geometry analysis is used in many of the, it has improved our understanding in not only biological process, in other physiological process as well. And the fractal concept is also being used in studying the structure and function of the brain, lungs, and even the skeletal muscles. Similarly, here we have used the fractal dimension in studying the protein structure of COVID-19 variants. Now coming to the challenges, one of the most challenging issue is the SARS coronavirus mutation changing the viral protein structure, the binding affinity and hotspot of the interface. This is the main challenge, so that researchers cannot get the clear picture of the protein structure of COVID-19 variants. And second challenge is the scarcity of COVID-19 data sets. And third is the virus non-structural proteins are still poorly understood. The COVID-19 consists of 29 proteins. In 29 proteins, 16 are structural proteins, 16 are non-structural proteins, 4 are structural protein, and 9 are accessory protein. Now coming to the research objective. In our research, we describe the arrangement structure of protein by fractal geometry analysis. Then we also analyze the protein structure of COVID-19 variant proteins. Then we compare the protein structure with other respiratory disease like influenza virus. Then coming to the literature survey, author Tom proposed this paper to calculate the fractal dimension of a complex network in the year 2007. The methodology was used as the box covering algorithm, is to find the minimum number of boxes to cover the complex network. The purpose is to calculate the fractal dimension of the complex network. The limitation was the greedy algorithm need to be applied many times, which is a time-consuming process. Then coming to the next paper, it was proposed to you. The paper was a new method for calculating the fractal dimension of surface topology. It was published in the year 2015. The methodology was used as the RMS method, root mean square value of surface heights. The purpose is to calculate the fractal dimension of topological surface in 3 ways. The limitation of the method was the calculating of theoretical fractal dimension is lower than 2.3. Then coming to another paper, which was published by Conradin in the year 2019, the fractal dimension of chromatin, a potential molecular maker for orogenous and protonus. The methodology was used for calculating fractal dimension. They used 3 methods, 3 techniques. That is the box counting, Minkowitz, and Einstein on microscopic images. The purpose is to find the mass fractal dimension is a promising maker for the early detection of carnogenous that can also be applied in chromophilics. The limitation is in this Bracey threshold is influencing the fractal dimension values and provoking the loss of information. The paper was published in the year 2021 by complexity analysis of the alteration and structure of coronavirus. The methodology used is the box counting algorithm that segments the genome walk using boxes of same size, find and count their number. The purpose is to investigate alteration in the complex structure of different coronavirus. That we cannot prove that such a coupling may always exist in the coronavirus. And another paper was published in the year 2022 by Ellington. The paper was fractal dimension analysis of the progress of cancer using transmission optical microscope. The methodology used was fractal dimension for random fractals determined using the box counting algorithm. The purpose of the cancer stage in progressive cancer raising possibilities for the physical-based accurate diagnosis method for cancer detection. The limitation of this method is the microscopic photographs were binarized at a grave value threshold, resulting in fractal dimension between 1 and 2. Now coming to the methodology. In our research, firstly, we collected the PDB files of COVID-19 proteins. Then we constructed a protein structure network. After that, we have calculated the shortest part between every pair of the nodes in the PSN. Then we have calculated the ball ability of PSN with different box size. Finally, we have calculated for the fractal dimension of the PSN network of COVID-19 variants. Now coming to the PDP files, the COVID-19 PDP dataset was gathered from the website www.rcbsp.org. The dataset consists of that includes alpha, beta, delta, and omicron variants of COVID-19. Each of the protein contains the nodes ranging from 97 to 109 nodes. And the contacts among the nodes vary from 1500 to 5236. The dataset includes a protein ID like 7EDI, 7DF, 7ED, 7EDG, and so on. Then after collecting the PDP files, now we have constructed the protein structure network for the COVID-19 proteins. In order to construct the protein structure network, firstly, we have extracted the C alpha atoms from the PDP files, their XYZ coordinates. The XYZ coordinates represents the arrangement of atoms in the 3D space. Here we have considered the C alpha atoms because it is the center point for every backbone of every amino acid that are present in the protein. After extracting the 3D coordinates, we have constructed the distance matrix using the Euclidean distance. Then, after constructing the distance matrix, we have extracted the distance matrix by putting a threshold value whose distance among the non-adjacent residues separated by the distance of around 7 Armstrongs or less are considered to be 1 and rest as 0. Then after that, the PSN network is extracted from these adjacent network where in PSN, the nodes represent the C alpha atoms and the edges represents the non-adjacent residues separated by the distance of around 7 Armstrongs or less. Now after PSN network, we have found the covering ability. For that, Firstly, we have calculated the shortest path for the protein structure network using the Diksha shortest path algorithm. Then we generated a similar ball of radius phi around each node. Then computed the selection function x of ij of phi, where x of ij returns 1 if the node j could be covered by the ball center at the node I, and 0 otherwise. Then we determined a membership function y of ij of phi that represents the possibility of the ball to cover a node j as a value ranging from 0 to 1. Y of ij of phi is exponential function, exponential of minus s of ij of whole square by phi. Determines a ball, then we determined a ball covering ability for the PSN network using this equation. N of phi inverse is equals to 1 by v into v minus 1. Sigma I tends to 1 to v, sigma j tends to 1 to v, or j not equals to I, x of ij of phi into y of ij of phi, where v denotes the number of nodes present in the PSN network.
Excuse me, ma'am.
Now, after calculating,
Ma'am, time is up. Please conclude.
okay. Then we have calculated the fractal dimension using the formula ln of n inverse minus ln of n of phi inverse by ln of phi. Then we calculate the fuzzy fractal dimension by taking the slope of the plot ln of n phi inverse versus ln of phi. Now, this is the PDP file. It looks in this way. We have collected the C alpha atoms and the XYZ coordinates. And these are the results. The PSN network of the beta variant, alpha variant, delta variant, and the Omicron variant look like this. And the ball covering ability for the protein structure network of COVID-19 of radius 3 was found to be 0.894. Then coming to the fractional dimension, or the fuzzy fractal dimension of alpha, beta, delta of COVID-19 are comparable, whereas the Omicron variant was little less compared to other variants. And then we also compared with other respiratory disease, that is the influenza virus. The data set was collected from the same website. And this is the protein structure of the influenza A protein and B protein. And the fractal dimension that we calculated found to be same for the influenza virus and the Omicron. In conclusion, here we calculate the fuzzy fractal dimension of the PSN and influenza virus using zinc concepts. And we also, interestingly, that the alpha, beta, delta variants have same fractal dimension, but that the Omicron variant, the fractal dimension decreased. And influenza and Omicron variant have same fractal dimension. Acknowledgement, references. Thank you. Thank you.
Okay, thank you, ma'am. Any query? Okay, thank you, ma'am.
Thank you.